Okay, so today we're going to start electrostatics. Now, if you did your grade 9 in New Brunswick, you would have learned about electrostatics in grade 9 science. And it's looking at the forces between charged particles. So the first thing we have to do is just a little bit of background that I think you probably already know. What is it that causes charge in a particle? Well, we know that there are two subatomic particles that have charge, right? There's three that you would know of, but there's two that have charge, so two subatomic particles, and they are the proton and the electron. And these are considered elementary charges. Now, unfortunately, that's incorrect. They're not really elementary charges. You could actually have charge smaller than that, but we didn't know that when we named them elementary charges. So the proton, so we still call them that. The proton is a positive elementary charge. And the electron is the negative. Okay? And they have the same elementary charge, it's just that one's positive and one is negative. Okay? That elementary charge, and you'll often see it written as 1e. The e doesn't stand for electron, it stands for elementary. 1e is equal to 1.602 times 10 to the negative 19 coulombs. And then whether it's positive or negative depends on if you're talking about the proton or the electron. Now, and this C is coulombs. Charge is measured in coulombs. Okay, named after a physicist whose last name was Coulomb. Okay, capital C. Now, just in case it comes up in the unit, a proton has a mass of 1.673 times 10 to the negative 27 kilograms, whereas the electron has a mass of 9.109. We usually use 9.11 times 10 to the negative 31 kilograms. We say the proton is massive compared to the electron because, look, negative 27 doesn't seem to be very massive, but it's almost 1,000 times bigger than an electron. And so, if I have something like a pin in my hand and I have something that's 1,000 times bigger, the thing that's 1,000 times bigger is going to be pretty massive. Okay? So now the question would be, so when something has a charge, it has to involve, that charge has to come from our charged elementary particles, but how does something get a charge? Like a negative object is negative y. It's negative because it's gained electrons. Well, how about a positive object? Is an object positive because it's gained protons? I'm hoping you say no. When an object either has a positive or negative charge, whenever it has a charge, it's either gained or lost electrons. Okay? So when we're talking about charged particles, charged objects, they've either gained or lost electrons. They're never going to lose protons. Think about the structure of the atom. The protons are inside the nucleus. If you're going to remove or add a proton, that's a nuclear reaction, right? Whereas removing or adding electrons are as easy as rubbing your hands together or scuffing your feet on carpet. Okay? Electrons are really easy to remove and add. Protons, not so much. So whenever an object has a charge, it's either lost electrons or it's gained electrons. If it's gained electrons, it's going to be negative. If it's lost electrons, it's going to be positive. And if it doesn't have a charge, then it means the number of electrons and protons are equal. Okay? Now, what happens if two objects with different charges are brought together? Yes, they won't necessarily like each other if they're have the same nature. And when we talk about nature, we mean if they're positive or negative. But let's suppose one is like a positive 3 and the other is a negative 5. Okay? what's going to happen here? Yeah, they'll attract, but what happens if I bring them together and touch them? What will happen to the charge? So positive 3 elementary charge, negative 5. So it means this guy has 5 extra electrons. This one's missing 3. And if we were to listen to the conversation between them, the positive 3 guy would be like, man, I'm so unhappy. I'm missing 5 electrons. I'm missing 3 electrons, excuse me. And you have 5 extra. Life's just so unfair. And the positive 3 one would just keep complaining and complaining until finally the negative 5 one can't take it anymore and would give the positive 3 an electron. So that now the positive 3 becomes a positive 2 and the negative 5 becomes a negative 4. And then this one would say, there, are you happy now? I've given you one. And then the positive 2's going to say, well, no, because I'm still short 2 and you still have 4 extra, so how's that fair? And so the negative 4 gives another one, and this becomes positive 1 and negative 3. You still have 3 extra, and I'm still short. So it gives another one, so this becomes 0, and this is now negative 2. So now the negative guy thinks he's done. There, I don't have, you're not short any. But you still have 2 extra. And so it doesn't stop until they equal out. So whenever you have 2 differently charged objects, they coming together and touching, there will be a transfer of electrons until they end up with the same charge. Now you could draw this out all the time, or you could realize you could figure out what that charge would be by just adding them together and dividing by 2. So plus 3 minus 5 is negative 2, divide by 2 gives you negative 1. The same will be true if they're both positive. Right? If they're both positive, there'll still be a transfer of charge because this one's only short 2 and this one's short 4. And so this one will give 1 electron, so it'll become positive 3 and this will become positive 3. So don't think if both objects are positive there won't be a flow of charge. There will. There'll be a flow of charge until they're equal to each other. Okay? So that's now earlier when I was doing this, I said these 2 would like each other, they would attract. These 2 wouldn't, they would repel. Hopefully, if you remember nothing else from grade 9 science, you remember that opposite charges, objects that have opposite natures, like one's positive and one's negative, will attract. Objects with the same nature, either both positive or both negative, will repel. Why are they attracting or repelling? Because they're putting a force on each other, right? And so just like the Earth puts a gravitational force of attraction on us, and just like any 2 masses in the universe put a gravitational force of attraction on each other, any 2 charges in the universe put an electrostatic force on each other. Not necessarily attraction, it could be repulsion. So the electrostatic force its symbol is FQ because the letter for charge in an equation is Q. And the great news is the electrostatic force is going to mirror our gravitational force. Remember our equation for gravitational force was Fg is equal to G m1 m2 over r squared, where this was the force of attraction between any 2 objects that have mass. Well, our electrostatic force is going to be Fq is equal to kq1 q2 over r squared, where the q1 and the q2 are the charges of the 2 objects, measured in coulombs. Okay? The r is just like the r in the gravitational equation. It's the distance from center of one object to center of the other. Distance from center to center. Of course, measured in meters. And the k, just like the g was the universal constant in gravity, the k is called the electrostatic constant.